Comparison between coupling method, parameter RC coupled, transformer coupled, direct coupled. In coupling components, resistor and capacitor. Impedance matching in transformer coupled, transformer direct coupled. Block DC parameter RC coupled yes, transformer coupled yes, direct coupled no. Frequency response RC coupled flat middle at middle frequencies, not uniform, high at resonant frequency and low at other frequencies, flat at middle frequencies and improvement in the low frequency response. Impedance matching RC coupled not achieved, transformer coupled achieved, direct coupled not achieved. DC amplification RC coupled no, transformer coupled no, direct coupled yes. Weight RC coupled light, transformer coupled bulk and heavy. And here drift not present, not present, present. Hum not present, present, not present. Application used in all audio small signal amplifiers, used in record players, tape recorders, public address system, radio receiver and television receivers. Used in amplifier where impedance matching is an important criteria. Used in the output stage of the public address system to match the impedance of loudspeaker. Used in the RF amplifier stage of the receiver as a tuned voltage amplifier. Used in amplification of slow varying parameters and where DC amplification is required. Common emitter cascade amplifier. Common emitter cascade by capacitor. H parameter equal circuit for common emitter cascade amplifier. H parameter equal circuit. Cascade amplifier. Cascade amplifier here connected T2 emitter connected to T1 collector. Is having T2 having R1 or resistance in base side. Here T1 R3 R4 capacitance output DC connected load resistance. Signal voltage, signal resistance, AC equivalent circuit. H parameter equal circuit for cascade amplifier. H parameter equal circuit for cascade amplifier. H parameter equal circuit when output is shorted. H parameter equal circuit when output is shorted. H parameter equal circuit when IB equal to 0. Common emitter, common collector amplifier. Unless for first stage. Common emitter, common collector. Common emitter, common collector. Darlington transistors. Darlington transistors T1 emitter connected to base of the transistor T2 in Darlington transistors. AC equivalent circuit for that Darlington transistors. Parameter input resistance, current gain, single stage RA equal to 1 plus HFE into RE equal to 168.3 kilo ohms. In Darlington, Ri equal to 1 plus HFE square Re divided by 1 plus HOE into 1 plus HFE into Re equal to 1.65 mega ohms. Current gap A equal to 1 plus HFE equal to 51. A equal to in Darlington where 1 plus HFE square divided by 1 plus HOE into 1 plus HFE into R equal to 500. Bootstrap emitter follower. Bootstrap emitter follower. Here also connecting R3 through C in RE, R1, R2 in base supply connecting VCC, load resistance, source resistance, single voltage, single capacitor, V1 across this, here R1, RI, here VCC, connecting here, and then capacitor connected VCC, give me the common emitter, base connected, source resistance, signal voltage, signal resistance, capacitor, RM1 connected, R3, R1, R2 connected in base, in between supply and common ground, common, in between R2 and R3, C capacitor connected and RM2 also connected parallelly, RE load resistance, emitter resistance, here output, so RM 1 RI, this is the RI here, RI dash here, RI dash here, RM1 R bootstrapped Darlington circuit. This is the racing button. This emitter connected to the side transistor base. Yes, econ circuit for bootstrapped Darlington circuit. This is Darlington circuit connected. Bootstrapped Darlington circuit alternative approach. Yes, econ circuit. Bootstrapped Darlington circuit alternative approach. AC ground circuit, bootstrap, yeah. Bootstrapped Darlington circuit alternative approach. This Q1 emitter connected to Q2 base, R1, R2, R3, R3, R3 connected to in between Q1 base and in between R2 or R1, R2 resistance. Signal voltage, signal resistance, capacitance. Then from here, capacitor connected across these in between emitter and R1, R2, R3, RE emitter resistance. Output here is Q2, this is Q1 transistor, this is supply here. AC equal circuit. Frequency response of an RC coupled amplifier, bandwidth of an amplifier. Here in X circuit frequency, Y circuit voltage output gain. Low, high, mid frequency region, low frequency region, high frequency region. Ideal frequency response of a practical amplifier. Low frequency range, this range, high frequency range, mid frequency range. This is where we have our voltage gain. Y-axis, x-axis frequency. Ideal frequency response here. This one. Frequency response of a practical amplifiers. This one. Frequency response of an RC coupled amplifier. Bandwidth of an amplifier. Here, frequency response of power frequencies at bandwidth of an RC coupled amplifier. X-axis frequency. Here F1 at 0.707 AV midday. AV midday here also in mid frequency region. This one. Voltage gain. Y-axis. Here F1 AV midday. Correspondingly here draw the line, then draw. This is the bandwidth frequency, mid frequency region. In between this mid frequency region, this is bandwidth. Frequency response of our frequencies on the bandwidth of an RC coupled amplifier. Hybrid by common emitter transconductance model. Hybrid by common emitter PJT model. RBB, RBE, RB dash E equal to 1 by G B dash E. Common emitter, common capacitor emitter P dash R B dash C equal to 1 by G B dash C well RCE 1 by GCE GM BB dash E. C collector emitter, base emitter, common emitter. Hybrid by common emitter PJT model. Classification of amplifiers. Amplifiers can be classified broadly as voltage amplifier, current amplifier, transconductance amplifier, transresistance amplifiers. Voltage amplifier, the circuit is a two-port network and it represents an amplifier. Suppose Ri is greater than Rs, drop across Rs Rs is very small. Rs Ri is greater than what? Rs is very small. Here it is very small only. Okay. Equal circuit for voltage amplifiers. Current amplifier. An ideal current amplifier is one which gives output current proportional to input current and the proportionality factor is independent of Rs and RL. An ideal current amplifier is one which gives output current proportional to output current proportional to